is the number of phases of a correct risk management process. These phases, which might not be rigidly sequential, offer a complete response to the need to manage uncertainty. These phases are: risk identification. This phase objective is to obtain a list and description of the risks to be analyzed and then managed in the subsequent phases. Risk assessment. In this phase, the probability of occurrence and the impact of risks are assessed and measured through qualitative or quantitative analysis tool. Risk treatment plan. In this phase, the actions to prevent the risks must be planned and organized to be actionable. We will particularly focus on active risk management, including avoiding, mitigating, or transferring the risk. Contingency management. In this phase, we will protect the project from the impacts of residual risks. This is a form of passive protection. Contingencies are budget provisions like money set aside to cover the possible negative effects of risky events. Finally, the last phase is risk monitoring, reporting, and control. During this phase, we verify that the activities are carried out continuously to monitor the progress of response actions and contingencies. We identify new risks and monitor the existing approach's evolution. Let's view now each phase more in detail. The objective of the risk identification phase is to define the risks that could impact the project. In particular, the aim is not to generate the broadest and most exhaustive list of factors that may affect the project performances. Such a list could be endless and useless, but to define the main project risks, the aforementioned known unknowns. As said earlier, risks can arise from many factors, from the variability of initial estimates, particularly time and cost, from organizational complexity and the number of stakeholders involved, from internal company factors, from factors related to suppliers, or even from the external context. There are multiple methodologies that the project management team can use to identify risks, as brainstorming, Delphi methods, SWOT analysis, fishbone diagrams, and many others. We will not go into these techniques here for the sake of time. But it is important to stress that the identification phase must always be carried out with a double logic. On the one hand, a backward look to capitalize the experience gained on projects in the past. On the other hand, a forward look, seeking for those characteristics that make this project unique and therefore cannot be identified through the experience. It is crucial, however, to take a closer look at how risk must be defined. Many mistakes in risk management arise from an incorrect risk definition. It is not uncommon to find in risk registers some risks like country risk to indicate unstable social or political conditions. Unfortunately, this definition is harmful rather than just useless, because it does not support the subsequent risk assessment and risk treatment plan phases. Instead, there is a precise syntax that should be respected. Due to, if, then. Thus, for a construction project, the risk of severe weather conditions does not allow us to appreciate either its probability of occurrence or its impact, and eventually does not support the generation of possible management responses. Instead, the correct way to define such a risk might be due to the fact that the project will be carried out in the winter in an area historically subject to prolonged adverse conditions. If temperatures below -20 Celsius occur for more than 10 days in a row, or in any case for more than 15 days in a month, then the milestone start of on-site building activities will be delayed, resulting in project delays between 15 and 30 days. During this time, salaries, board and lodging costs will be paid for the team of 10 skilled technicians while waiting to restart the project. Defining the risk in this structured way allows identifying the impacted milestone, start of the on-site building activities, and what are the expected impacts on the project schedule and cost. Moreover, such a structured definition will help identifying prevention actions, the so-called active risk management, that act on the route or on the event, from protection actions, passive risk management, that just set aside resources for covering the impacts in case of risk occurrence. When risks are correctly defined, it is possible to move to the second phase of a management process, the risk assessment. The risk assessment is carried out to examine the identified risks, define a priority index, and select those on which an action is mandatory, those which must be carefully controlled, and those that can be accepted without performing any action. Two key parameters characterize each risk. On the one hand, the impact, negative or positive, in case it is a risk or an opportunity. On the other hand, the probability of the event's occurrence. These two parameters can be assessed using either qualitative methodologies or quantitative ones. In this course, we will focus only on qualitative analysis for the sake of time and complexity. When running a qualitative analysis, we assign to both the probability and the impact a qualitative value, for example using a high, medium, low scale, or a qualitative numerical scale from 1 to 5. The synthesis of this evaluation is often captured using a probability impact matrix. The PI matrix also shows the risk factors evaluation, defined as a product of a probability for the impact of the risk, and the thresholds, typically colored green, yellow, and red, that identify the different actions required. Risks in red zones are not acceptable and require intervention. Those in yellow zones may or may not be subject to intervention, but should anyway be monitored carefully. Those in green zones can be accepted without any action. The probability impact matrix construction does not have particular complexities, but it does involve the very serious risk of a high level of subjectivity in the evaluation. Since the evaluation is qualitative and the risk appetite can be very different between different people, the same risk on the same project may be placed in the green or the red zone depending on the assessor. This variance can dramatically reduce the validity of the whole process and must be reduced. A possible solution to this problem is clearly defining the scales to be used and associating each scale value with concrete examples to make the assessment more objective. For example, it is possible to provide clear and univocal reference points to define the impact in terms of schedule, cost, and quality. In this table, we see that the impact on the schedule should be considered critical if it results in a critical project delay from schedule duration more than 40% of the duration, and it can bring to project termination. If the effect of a delay is a serious shift of a scheduled project end date between 20 and 40% of the duration, the impact should be considered severe instead. In a similar way, it is possible to describe all the degrees of impact till the very low one. In case there is a negligible impact on the scheduled project end date that does not result in any rescheduling. Similarly, it is possible to define a scale for the impact on costs, from critical, if it implies a project cost escalation greater than 20%, to very low, if it implies a negligible impact on project cost that does not result in any rebudgeting. Finally, A similar scale can be designed for measuring the impact on quality. From critical, if the effect is visible to the client, there is a failure to meet at least one critical project requirement and this may cause project termination, to very low. If the effect is not visible to the client, it implies a minimal or negligible impact on functionalities. The definition of the probabilities is, if possible, still more subjective. Therefore, it is advisable to create a scale per each macro categories. First of all, the different outcomes are often not homogeneously distributed. In this example, a probability is considered very low if it is under 10% and very high if it is over 70%. This not symmetrical distribution is meant to increase the probability of a risk of being in the red zone and consequently push the project management team to take action against risks. Moreover, in this case, two risk categories are analyzed: risks related to human resources and to suppliers. Once again, specific examples are provided to guide the assessment. The probability of having negative events because of poor performing human resources will be considered very high in the case of limited resources with no experience. On the contrary, it will be considered very low in case all the required resources with experience are available. Similarly, the probability of having negative events because of poor performing suppliers will be considered very high in the case of new suppliers with low performances in previous projects, or very low in the case of known suppliers with good experience in similar projects. The careful and precise definition of reference scales is an essential step in the qualitative assessment of risks, and their absence inevitably involves a level of subjectivity that severely undermines the quality of the entire risk management process.